Hello, I'm going to show you how to solve this differential equation using the Laplace transform. And this is an equation you could solve using a different method, but we'll just go through it because it's a pretty easy place to start just to get the steps down. So the first thing you want to do is take the Laplace transform of every term in the equation. And in this one, that's pretty easy to do. You could just do it from a standard Laplace transform table. So let's see what that would look like. And so from here, taking the Laplace transform of y prime of t, and by the way, the dot over y is just means it's a derivative, and I've written the t's in just to be specific. You know, you might see this as y prime plus y equals sine t. All right, so taking that, you would get, and it's shown right here, Laplace of y prime equals s times y of s minus y of 0. What is y of 0? That's our initial condition, which is given here. It says y of 0 equals 0. That just sort of keeps it simple. So the Laplace transform of y prime will just be s times y of s. And just a note, a clarification, I wrote capital T there for sine. It should be lowercase, so not a huge deal. Now the Laplace transform of y of t, that's just capital Y of s. And for sine, again, this comes right from a table of Laplace transforms. You get 1 over s squared plus 1. So when you put those all together, you get this equation here. And you want to solve for y of s at that point. You've written that here, yeah, solve for y of s. So what you get is y of s equals 1 over s minus 1 times s squared plus 1. And ideally, right now, you would take the inverse Laplace transform and solve for that. But it's pretty difficult to do in this form. So you have to do a partial fraction decomposition, which is really common for these problems. So you want to brush up on that if you have a test coming up and you have to do some of these Laplace transform problems. So basically you write the fraction in this form where a0, a1, and a2 are constants. Okay, and then we're going to solve for a0, a1, and a2. And the first step in that would be multiplying the denominator. So I multiply by s minus 1 times s squared plus 1 on both sides. And this is what I get. So after multiplying both sides by the denominator, that is your equation. You get these, the denominator terms will cancel out here, and you're left with this. And from here to get the constants, we just want to be clever and substitute some strategic values. If you pick s equals 1, then you would see that you get a 0 here, so this term goes away, and you're left with this. 1 equals a2 times 2, basically. So solving for a2, you get 1/2. Now that you know a2, I'll pick another clever value, 0, because this makes one of our terms go to 0, and we're left with what's down here. You get a1 equals minus 1/2. And I didn't show the substitution for the last one, but if you take the initial equation here, and you put in 1/2 for a2 and minus 1/2 for a1, you should get that a0 equals minus 1/2. So now I just substitute those values back into this equation here, and what you would get is this. You notice they all have, well, 1/2 is the leading coefficient for every term, so really you could factor that out. That would actually be a nice step to do here. Okay, and then cross these ones out. So once it's in this form, it's really very easy to take the inverse Laplace transform of, well, especially for this one, because 1 over x minus 1, x over x squared plus 1, and 1 over x squared plus 1, those would come directly from the table. You don't really need to manipulate them at all. So I've shown it here, and I just use L to the minus 1 as my inverse Laplace operator. And you get y of t equals 1/2 times e to the t minus sine of t minus cosine t. And at that point, you're done. And you have your solution. I encourage you to solve this a separate way as well. You could find the homogeneous solution and the particular solution, okay, and that will equal y of t. Alright, so I hope that was helpful. If you liked the video, please click like and subscribe, and keep an eye out for more videos. See you next time.